Hello, everyone. Welcome to the last week of the semester where you will be doing the last experiment of this course. So hopefully many of you have already gotten started with watching the lecture videos for this lab and even started on the lab a little bit. In this lab, we'll be exploring diode rectifiers and regulators. So in this briefing video, I won't be going over the theory for rectifiers and regulators. They're more than adequately discussed in the pre-recorded lecture video that's posted on Brightspace as well as on the course website. Instead, because this lab is going to be fully on LT-SPICE, and many of you may not be familiar with some of the more advanced features, moderately advanced features of LT-SPICE. So I'm going to take this time to go over some of those features, methods, techniques that will help you complete this lab easily. Right. So part of the reason why we're doing this lab in LT-SPICE is that the 82 does not have the power capabilities and the voltage capabilities that you will need in order to perform this lab. Okay, so the three things I will highlight here is how do you add a specific diode model into the LT-SPICE schematic. The second thing I will talk about is the placement of ground node and how to measure differential voltages on LT-SPICE. And the third thing is how do you get the RMS measure of a signal once you have simulated the circuit. Okay, so for this, I'm going to use an example circuit. And it's going to be, I'm going to make an example circuit out of what's called a level shifter using a diode. So I'll place a voltage source, a capacitor, a resistor, and then finally a diode. And then we'll start by giving these values. So we'll give this a 1 microfarad capacitor, make this current limiting resistor 100 ohms. And then I'll make the voltage source a sinusoid with, say, amplitude 3 and a frequency of 1 kilohertz. And now finally, we have the diode. Right now, this is just an ideal diode, but we want to use a particular diode, simulate a particular diode using its circuit model, right? So to add a particular diode, we will, first of all, right-click on this diode and then click Pick New Diode, okay? And from here, you'll be presented with a list of available diode models from which we will pick the one that we want. So in this case, I'm picking the 1N5819 Schottky diode. Now I'll add that. So now this diode is using the 1N5819 diode model. Okay, so the circuit is almost complete. Sometimes in circuit schematics, you will not be shown the ground because ground is an arbitrary reference. In most cases, it's when building the circuits, we use the ground for the source as our reference ground, and that's most natural. But as you will find in this lab, that there may be multiple references that make sense. In particular, for the full wave bridge rectifier, you can. It's natural to consider the negative terminal of the supply source to consider as ground, or it may make more sense to consider the negative terminal of the output as the reference ground, right? So depending on the circuit, it may make sense to use one or the other voltage nodes at the reference. Okay, so To begin with, I'll place the ground node here. And now we're ready to simulate the circuit. So we'll simulate the circuit with transient simulation for 10 milliseconds. Put that on the circuit. Before we do any simulation, I'll just place some useful labels onto the nets. And then finally, now let's simulate this circuit. And as you can see, the output voltage has this profile. Okay. Now, okay, so right, if you wanted to also plot the input voltage of the circuit, you can click on the input voltage and voila, you have the 3-volt sinusoid, right? Okay. So this is an example where we place the ground in the negative terminal of the supply source, but I could have easily placed the ground somewhere else. Let's place the ground somewhere. It doesn't really make sense, but it will not change the simulation. It will only change how we need to measure the different voltages. Okay, so let's run the simulation again. And now if I plot, let's first try and plot the input voltage. You would naively think that this, when I click on this node, I should expect to see a 3 sine wave with amplitude 3, right? But we're going to see something else. And that's because right now we're actually measuring this node voltage with respect to this ground. Or in other words, I'm measuring the voltage across the capacitor. Right? The voltage of the input voltage is actually the voltage across, the differential voltage across the supply. And in order to measure that, I can what I can do is I can measure this voltage by clicking on the one end, dragging it, and then placing the cursor on the other end. And that way I can measure the differential voltage across 2 nodes. And now this is what we expect, right? A 3-volt sinusoid, a sinusoid with amplitude 3 volts and period 1 kilohertz frequency. Okay. Similarly, if I wanted to measure the output voltage, if I simply click here, that will give me the negative voltage across R1. But instead, I want the voltage across the diode. So I can click, drag, and drop to the next voltage, and I'll see this voltage across the diode. Okay. So that is how you measure a differential voltage on LT-Spice, by clicking, dragging, and dropping. Okay. Right, so next, what we can do is talk about how to measure the RMS voltage of a signal. Right? So I've got this transient voltage, and now I want to measure the RMS of the signal. And to do that, I'm going to press Control and click on this label, and that will bring out this pop-up screen, which gives me the average of the signal as well as the RMS of the signal. As simple as that. Now, in several cases, what we're really interested in is the RMS after the signal has reached its steady state point. Okay, so by that I mean, if you look at the initial part of this graph, it looks different from the rest of the graph, right? Towards the end, it is a more periodic signal, whereas towards the beginning, it's gradually dropping, right? So this is what we call an initial transient. And we don't want to, what we want is actually to calculate the RMS of the final transient. Okay, so just this part. In order to do that, what we can do, well, first of all, why would we want to do that? So in this task, in this lab, for the rectifier and the regulator circuit, what you'll see is that the output voltage will have some initial transient for the capacitor to charge up. But that's really not what we're interested in. What we're interested in is what happens after everything settles down, and what we as humans or experimenters will actually see the circuit doing, right? So the initial transient is, it happens, but it's not what we're really interested in. So if we want to just capture the RMS of the steady state, what you want to do is there are two methods. One, you can zoom in to the section where it is in its steady state and then get the RMS. Or the other method is we can change in the simulation command the time to start saving data. So if I say I want to start saving data only after 3 milliseconds, that will just ignore the initial transient. Okay, and then if I run it, then it'll only give me the steady state. Okay, but for this, you'll first have to do the simulation and find out when this system has reached its steady state point. After this, if I click on this label again, I will get the RMS value, and this is the RMS of the signal in its steady state. Okay, so with that, talked about how to add a specific diode, how to measure differential voltages, and then how to measure RMS for a signal, and also for steady state part of the signal. So with that, I'm going to end this lab briefing. If you have any questions regarding how to do different measurements on LT-SPICE or any questions on the lab itself, do feel free to ask. Otherwise, I hope you guys have a fruitful rest of the semester and good luck for the exams. Thank you.